So this will be a little bit more like a seminar to start with and a little bit less like a lecture in class. But let's go ahead and start our discussion in terms of molecular orbital theory. So where we had left off with was we'd fully discussed up to the point of considering homonuclear diatomic molecules, so molecules that both have the same nucleus. And where we had left off was we were going to start one example of thinking about now where we have a heteronuclear diatomic molecule, so two different atoms in terms of forming the molecule. But first, I just want to remind you, when we're talking about molecular orbital theory, this is treating electrons as waves. So what we're actually able to do is either constructively or destructively combine atomic orbitals to form molecular orbitals. So you should remember that anytime we combine two s orbitals, what we're going to find is if we constructively interfere those two orbitals, we're going to form a bonding orbital. And that's going to be lower in energy than the two individual atomic orbitals. And we call that, for this case, our sigma 2s orbital. In contrast, if we have destructive interference, what we're going to form is a sigma 2s star. And what does the star designate? Antibonding, yep. So it's an antibonding orbital. It's going to be higher in energy than the individual atomic orbitals. All right, great. So I think we have these molecular orbital energies down. So let's